Hi guys, welcome to Aisha.Academy, and today's video is going to be all about surds. So let's get right into it. Let's not waste time. So when it comes to surds, they are basically square roots of non-square numbers. So normally examples of these would be, for instance, here when we've got root 6, so we know root's not a squared number, so we can't really simplify it any further. And another example is root 7, and another example is root 13. So these are all examples of surds. So remember, squared numbers are not surds. Why? Because they can be simplified when you square root them. So for instance, if we've got root 25, we know that the square root of 25 is 5, and so therefore it is not a surd. Another example, if we have root 9, square root of 9 is 3, and so that is not a surd. And lastly, if we look at root 49, we know square root of 49 is 7, so therefore these examples are not surds. So moving on to simplifying surds. So when it comes to simplifying surds, basically when you're simplifying them, you need to separate the number into a square factor, so a squared number factor, and a non-squared number factor. So I will go through examples of these to make this statement clearer. So if we have a look at example 1, if we have the square root of 8 two numbers that we can think of factors of 8. One that's a squared factor of 8 is 4, because we know 4 is a squared number. And another example of a non-square factor of root 8 is root 2. And so the root 4 is therefore going to simplify into 2, but the root 2 cannot be simplified any further, so that will be kept as root 2. And so the final answer of root 8 simplified as a surd would be 2 root 2. We would squash them together like we do in algebra when we multiply, for example, 2 times x. So it'll be 2 times root 2. Another example of simplifying a surd. So if we have the square root of 45, so root 45, two factors that we can think of that make 45. So a squared one would be root 9, so that would be our squared number factor. And then our non-squared number factor will be root 5. So that would be our non-squared number factor. And so the root 9 would simplify into 3, and because we know that root 5 cannot be simplified any further, it would just be kept as root 5. So the final answer for root 45 being simplified as a surd would be 3 root 5. And that would be the final answer for that. So moving on to multiplying surds and dividing surds. So when it comes to multiplying and dividing surds, you basically want to multiply and divide the numbers in the square roots together. So we'll go through 2 examples of multiplying and 2 examples of dividing. So first example of multiplication, if we have root 3 multiplied by root 7, because we're going to be multiplying the 2 numbers within the surds and the surd is going to stay there, we're just going to end up with root 21. And this cannot be simplified any further, so that would be the final answer. Another example of this. So now I've showed an example where you've got a surd with a number outside, because sometimes that can confuse people. So for instance here we've got 3 root 2 multiplied by 2 root 5. So in this scenario, what you would do is that the 2 numbers outside of the surds would be multiplied together. So we're going to do 3 times the 2. And then the 2 numbers within the surds, aka within the roots, are going to be multiplied together. So the 2 times the 5. This would leave us with 6 root 10. And because this is its simplest form, this would be the final answer. So looking at example 3 now, where we're going to be looking at examples of division. For instance, if we have root 35 divided by root 7, we're going to again divide the two numbers within the root. So 35 divided by 7 would leave us with an answer of root 5, and because this is its simplest form, that's its final answer. And then the last example of division that we're going to look at is, for instance, again I've given another example with a number outside of a root to show you those examples. So if we have 3 root 3 divided by root 3, in this special scenario, we've got a root 3 before the division sign and after the division sign, so they would cancel each other out. So therefore, the answer is just going to be 3. Now we're going to look at adding surds and subtracting surds. So when it comes to adding and subtracting surds, it only works when the surds are both alike, so really similar to algebra. So understanding algebra will really help with understanding surds. So for instance, looking at adding, if we've got 4 root 5 plus 7 root 5, because both of the roots are the same, we could just add the two numbers outside together. So that would just leave us with 11 root 5. And one thing I want you to notice is that the root 5 has not changed. And this is very similar, for instance, if you were adding x's together. For instance, 4x plus 7x, you would get 11x and your x wouldn't change. So that same principle applies to surds. And once you understand that, it's going to make life 10 times easier for you. Another example of adding surds. So for instance, if we have root 45, also subtracting surds, if we have root 45 minus root 20, in this case it's very important for the two roots to be the same, and so therefore we need to simplify these surds. We wouldn't just take them away from each other, and so you would end up with 3 root 5 minus 2 root 5, which would leave you with an answer of root 5. So those are our examples of adding and subtracting surds. So now on to practice questions. So if we have a look at example 1, so it says rationalize the denominator of 12 over root 3. So when it comes up with questions of rationalize, a lot of times these can confuse students. So basically you're going to multiply the top and the bottom of the fraction by the surd that's the denominator. So in this case, our denominator of a surd is root 3. So we're going to multiply the 12 by root 3, and we're going to multiply the 3 by root 3. So for instance, with the 12 root 3 times root 3, that's just going to be 12 root 3. They would be squashed together like in algebra. And then for the root 3 times root 3, when you're multiplying the same surd, the answer is just the number inside the surd, so that would just be root 3. Then you're just going to divide the 12 by the 3, which leaves you with 4. And then the root 3 is not going to change, so your final answer is 4 root 3. So, for example, 2. So, if we have 5 root 3 root 5 bracket times root 8 plus root 18, we're basically going to end up expanding brackets, which is very similar to expanding brackets when it comes to algebra as well. So I've got a video on the top of expanding linear brackets if you need some refreshing on those. So in this case, we're multiplying the two surds. Remember, we multiply the two numbers within the surds. So root 5 times root 8 would leave us with an answer of root 40. And then root 5 times root 18 would leave us with an answer of root 90. And then we're going to simplify these surds so we can actually add them together. So that would leave us with 2 root 10 plus 3 root 10. And then remember, the root 10 will not change when we add them together. So that would leave us with 5 root 10. So last example is if we have this case. So it's going to be expanding the brackets. So expanding the brackets. So we've got root 12 minus root 3. And they're going to be multiplied by each other. So again, with expanding brackets, so you're going to have your root 12 times your root 12, which again, remember, multiplying two surds that are the same, the roots cancel out, so that's going to leave 12. And so the same thing's going to happen when we do negative root 3 times negative root 3. We're going to be left with positive 3. Because remember, two negatives multiply and make a positive. Then we're going to do root 12 times minus root 3, which would leave us with negative root 36. And then lastly, we're going to do the other minus root 3 times root 12, which is going to leave us with negative 36 again. All this will be simplified, so the 12 plus the 3 will give us 15. And then if you've got minus root 36 minus root 36, that would basically be minus 6 because root 36 is 6. So doing all that would leave you with a final answer of 6.